Hello, hi, namaste. Welcome to all. Today we will discuss Cournot model. This model, also known as simultaneous quantity setting. In oligopoly market, the Cournot model explains how different firms under oligopoly market set their quantities. Let's start the Cournot model. This Cournot model was introduced by France economist Augustin Cournot in 1838, before 200 years. Okay, the these models, Cournot models, basically describe how decide how much to produce, and the farm's decisions are taken at same times, so that is two farms are simultaneously trying to decide what quantity to produce. Okay, they are come together and set their quantity for how much we produce this. So to decide how much to produce, and every farms has to forecast what his opponents do. That is, each farms has to forecast what the other farms output will be in order to make sensible decision itself. Okay, now consider you are a farm 1 and I am farm 2, and we are compete each others. Okay, both are opponents. Okay, let's then I decide how much to produce. That depends upon what you are producing. Okay, and your decision to produce, it depends upon what I am producing. Let's say if I am producing 10 units of particular x good x, then what you are going to produce. If I am producing 50, then what for what is your quantity of production, so that then we can set our quantity decisions. Now let's consider a models. Okay, and every market, whether it is monopoly, oligopoly, perfect competitive market, every firm has a demand functions. Okay, that demand function describe what is the quantity demanded by given a particular price. So quantity is function of price. Okay, since the monthly in the since oligopoly market has a for a particular product called say x, the demand for function demand for that market demand for that product can given as q is function of p, and that inverse demand function can be written as p is function of q. Okay, p is function of q. Then uh, this is called inverse functions. Okay, demand function, inverse demand function, and the price market price is function of quantity demanded, and this quantity demanded is nothing but sum of two firms demand. Okay, the quantity q1 for farm 1, q2 farm 2's demand, and every farm's aim is to maximize his product, his sorry profit, maximize his profit. So both farm is profit maximization farm, so they'll decide how much to produce. Now, after that, we we have a concept called reaction curve. And what is the reaction curve? Reaction curve shows uh, that means what is farm one reaction with farms two outputs. That means if farm 2 decide to produce, let's say, 10 units of production, so what is the decisions, what is the reaction of farm 1? If farm 2 changes its quantity 10 to 20 to 30, 30 to 40, then what is the decisions, change in decisions of farm 1? It may be increased, may be decreased. So the relations between the expected output with the given farm two outputs. Okay, if there is given farm 2's output, then what is the expected output? So this shows the expected output produced by this side, produced by the farm 1 quantity given the quantity farms 2's quantity. Okay, so to understand this in details, so we can go this through the diagram. Let's say the farm has a total demand D, where the D1, D2 is demand curve faced by the farm 1 and farm 2. Then if farm 2 decide not to produce, then sorry, if farm 2 decided to produce nothing, then farm 1 decide to produce 50 quantities, then how is it possible? Let's D1 0 means demand curve faced by farm 1 when farm 2's production is a 0, when farm 2 equal to 0, when farm 2 produce 0 quantities, so that the demand curve, this D10 demand curve faced by the farm 1. So respective D1 demand curve and MR1 is the respective marginal revenue curve. Okay, so at point the MC1 is the marginal cost curve intersect at this point, and the determine the 50 unit of quantity demand. So if farm 2 decide nothing, then farm 1 decide 50 quantities. Okay, let's consider another situations where this situation, if farm 2 decide 50 quantity to produce. Okay, okay, then the farm 2's demand curve fall by 50 units. Okay, so if you see particular D2 demand, D150 means demand curve faced by the farm 1, where farm 2 demand equal to producing 50 quantities. When the farm 2 producing 50 quantities, so that farm 1 demand faced by farm 1 demand will be 350. Okay, and respective demand, and there is a marginal revenue curve, the MR50, and it is and then set equilibrium upon this part and set quantity production of 50. So when the farm produce 50 units of farm 2 produce 50 quantity of output, and farm 1 will decide 25 units of quantity demanded. Again, if farm 2 decide 75, then farm 1 decide to 12.5. So this D 75 D175 where demand curve first by the farm 1, when the farm 2 is producing 75 units, so that MR175 is the marginal revenue curve intersect a marginal cost curve at this curve it is producing 15. So this is the reaction schedules. This is the reaction schedules. Okay. So if farm 2 decide 0, then farm 1 quantity demanded equal 50. So Q1 star Q2. This means quantity demand, the production of a Q1 is a function of Q2. That depends upon the Q2. As Q2 changes, Q1 quantity production will be changed by farm 1. So if 0, then 50. If farm 2 producing 50, then farm 1 producing 25. If farm 2 producing 75, then farm 1 producing 25. So as quantity production of farm 2 increases, farm 1 production will be decreases. So say the farm 1 profit maximum output, thus a decreasing schedules of how much it thinks farm 2 will produce. As farm 2 production increases, so the farm 1 will decrease their productions, and if farm 2 production decreases, farm 1 production will be increases. So that will be maximum profit. So the basically reaction curve shows that it is the expected output productions of particular farm 1. If we're saying the farm 1's reaction curve, this means what is the expected output of farm 1 given farm 2's output. If farm 2 output is equal to 0, what is the quantity production of farm 1? Okay, this curve, the reaction curve of farm 1 shown in the diagram. If this side y-axis we measures Q2 quantity, products quantity of output produced by the farm 2, and this is Q1, this is the quantity production of farm 1. Then this if farm 1 producing 50, then farm 2 will produce if farm 2 will produce 50, farm 1 production will be 25, and if farm 2 producing 75, then farm 1 producing 12.5. Okay, so it is the expected output of farm 1. So the reaction curve of farm 1 is declined, because as quantity out production increases farm 2, then farm 1 will be decreases. So this side is expected output of farm 1. Similarly, in second diagrams, lower diagram, this shows the farm 2's reaction curve, this flutters curve, and again, and this shows that the respective output of farm 2, this is the expected output of farm 2 given the farm 1's outputs. So both farms reaction curve are different, it's not equal to same, because if your productions, if farm 1's production is something, if farm 2's expectation will be different, and if farm 2's production is something, in farm 1's expectation will be different. So there is a different reaction curve. So that this reaction curve shows the behavior of farm 1. Okay, so the both farms behavior is different. We can understand this whole model through numerically. Two farms facing the following market demand curve, P equal to 30 minus Q. This demand P equal to 30 minus Q is a demand function, inverse demand functions. Okay, this is the inverse demand function, not direct demand function. This is inverse demand functions. Okay, where P is function of Q, inverse demand curve, and Q1 Q2 are, whose Q is the summation of Q1 Q2, and both firms have the 50 units of fixed cost. Okay, so that the farm one's profit functions would be difference between the total revenue minus total cost. Tier 1 means pi 1 means profit of farm 1. It's a difference between the farm 1's revenue minus farm 1's cost. Total revenue minus total cost of a particular farm. So TR total revenue can be written as Q1 plus P into Q1. P into Q1. The price of a product into how much quantity is produced. Okay, then total cost. So we know P is market demand functions for P equal to 30 minus Q. So if you put P equal to 30 minus Q and Q1 is there minus TC. Okay, TC is 50. So by 1 equal to profit of farm 1 equal to 30 Q1 minus Q1 square minus Q1 into Q2 minus 50. So the farm 1's profits depends upon both things in his product as well as farm 2's product. Okay, so the farm 1's profits not only depends upon the his product, his output, but also other competitors outputs. Okay, now we will look what is the farm 1's profit maximization output given farm 2's outputs. Okay, then the first order profit maximization condition is this much, and we put derivative with the pi 1. We already given the pi 1 profit function is 30 q1 plus minus q2 square minus q1 q2 minus 50. So we will get equal to set equal to 0, then we will get the function q1 equal to 15 minus equation 15 minus 0.5 q2. So this is the reaction curve, farm 1's reaction curve. That means the q1 quantity of farm 1 is depends upon the q2, as quantity of q2 value given, the q1 output only given, so that this curve is given as a function report. Similarly, farm 2 reaction curve will be given at a same way, because both are identical farms, both are same cost structures, so that automatically reaction curve is same. But if you see both curve, q1 function of q2 and q2 is function of q1. Okay, and both have negative signs. So the q1 is related to negative related to q2, and here q2 is negatively related to q1. Okay, so to get Cournot equilibrium, to solve two reaction curve. Okay, farm 1 reaction curve and farm 2 reaction curve. If you solve these two reaction curve, we'll get q1 q2 10, and total quantity equal to q1 equal to 10, q2 equal to 10, and total quantity will be 20. Okay, so what is the market price? The market price will be the function 30 minus q. Already we have given the price, market price. So this is q equal to total market quantity equal to 20, so it is given the 10. Okay, so automatically the farm's output will be decided. So this is all about the Cournot equilibrium. Thank you.